Yeah, good morning, team. Am I audible?
Yes, Veera, it's audible.
Shall we start? I need to wait for anyone. I think one more person had to join. Okay, let's get started. Now in this, I'm sharing the screen now. Okay, let me create a cluster now. So meanwhile, it will take some time to complete the cluster process. After that, we can discuss the topic in theory level. So I'm going to spin up a cluster now, CLI process again. So it will take time at least 20 minutes. So meanwhile, we'll discuss in today lab. Okay. So today we are going to focus services. So yesterday we already discussed, right? Services. We have a three type of services. The one is cluster IP and node port, load balancer. So the cluster IP process is my screen is visible, right? Can anyone please confirm my screen is visible?
Yes, Veera, it's visible.
Okay. So if you can see, yesterday we already discussed, this is deployment.yaml file. The deployment.yaml file, if you, okay, let me spin up this deployment. Okay, it will take some time, right? The cluster is in progress. Okay, the very important one, let me take from here, the deployment.yaml from here. Okay, so okay, so this is my deployment.yaml file. So now, if you want to give a access after create a deployment.yaml, so we need to create a service.yaml for this deployment.yaml. Okay. In this case, so I need to write a service.yaml to give a deployment access to external access. This service.yaml create a service for this deployment to give a access. The simple logic is. But here we need to understand very important thing here. Okay. So here we need to understand very important thing. My service is this one. Okay. So your service will communicate with your deployment based on these labels. So my service labels are, okay, this is my service. So this is API version, kind is service, metadata, service name, and these are service labels. And the specification is type of cluster IP or node port or load balancer. It will change here. And we have a port details and protocol and selector. So we'll discuss one by one here. So the very important one is this step. The selector app my app. Okay. Selector my app is nothing but this label should be matched with your deployment.yaml label. So if you can see here, labels are here, app my app. So the deployment and service will communicate based on this label communication only. This is step number one, understanding number one. We need to understand. And so how to communicate how to communicate your service with the deployment.ml. So we have a n number of deployments. Which deployment we need to give a service? Whatever deployment you are creating with respect to the same labels, only the service will be communicated with the deployment.ml. And here my three pods will be created. Okay, my three pods will be created. So these three pods will be give access to external or internal based on the service type. And after understanding this labels process, now we need to understand one more concept is ports concept. So we can see here different ports. Port, under ports column, we have a port, target port, and protocol. And the main important specification is which type of specification it is? Cluster IP. Okay. And in this cluster IP, service is going to be created. And so in the ports level, we have a port and target port. Okay. What is these ports? So we can understand here. Okay. Let's understand first. The process is yeah. This is okay. So this is very important understanding. So this is your pod. Okay, this is your pod. And understand this is entire node. This is node IP. This is your pod. So user is here outside of the node. So user can access this service through node port, node IP, node IP / node port. Even container process also, even Docker container process also. So Docker run -dt -p port, localhost port, and container port. Only two kind of ports there, localhost port and the container port. Whatever port you are going to enable on top of the node, that port plus the EC to IP, we are accessing means we are able to access Docker container. But here process is the process is similar to the Docker container, even pod access also, but here additional port is enabled. Coming to the picture here, the additional port is service port. So what we can understand here, this is node port, this is your pod. So if you want to give a access this pod to external, we have to create a service. So we are creating a service. This service will help to allow this pod access to external or other pod access, internal communication. Depends on the type of the service. So in this case, if you can see here, okay, if we can see here, we have a pod, we have a node, but also we have a service. So here, this service will help to allow the communication from external to internal for this pod. So if I access my node IP node port, the service will enter into the service. I mean, the request will enter into the service. Service will throughout this now. So whenever you can create a service, the service will enable the port forward option from here from incoming traffic to pod, ongoing traffic to pod. So now here we have a port number, target normal port, node port. Okay. So node port is nothing but enable for node level. This is node port. Service port is nothing but this one, middle one. Port is nothing but service port. And target port is nothing but Kubernetes pod port. Okay. So whenever you can create a service, by default, two kind of ports we need to define. Port number one, that is target port, where exactly your application is running on default port, that is target port. And in between node port to your target port, we have a one more service, right? The service port also we have, that is this one. And what about node port? Node level port. So if you create a service, node port service, see here, the understanding is this node port, if you define or not, no problem. The reason, whenever you can create a service, node type service I'm talking about, node type service, Kubernetes node port range, if you can check here, 30,000 to 30,000, 30,000 to 32,076. This is the port range by default. The default port range for Kubernetes node port is 30,000 to 32,767. If you define, whenever you are creating a service, node port service, if we can define here, the port is required 3008. Kubernetes default, by default, allocating this port for this entire service process. Or if you can see, the defined port number also should be range in between 30,000 to 32,000 change in between only. Or if you are not defined this port, by default system can allocate the port in between the range, in the range of 30,000 to 32,000. Okay, this is understanding of node port. And target port, once again I'm saying target port is nothing but your application default port. For example, your application is Nginx, the port number is 80. Your application is Python Flask, the port number is 5000. Your application is Node.js application, the port number is 3000. So depends on the application, we have to define the target port. Target port means where exactly the port your application is running as default port, that is target port. So middle port is service port. So here the communication node to node port to or node to your pod where exactly application is running, both can communicate through this service only. Okay. So when we are creating a service, means we are creating this block to communicate this one and this one. Okay. Let's check my cluster status. Cluster grid is running. And okay. And next, if you can see here, cluster IP, whatever cluster IP or load balancer or node port service, three services are same YAML file, only type will change. Cluster IP or node port or load balancer. Rest all the same. Rest all the same. Okay, but how deployment and service will communicate based on the this block. Selector block you can give here or here also, whatever. This label and your replica set label should be matched so that your service will communicate with these pods. Otherwise, this service will create, but it will not communicate with your pod, means it will not give access to, this service will not give access to public. This service, this pod, both can communicate based on the labels. Okay. Same thing. We have a load balancer type. Load balancer means here we have to define load balancer. Load balancer will be created. Any questions?
No, Vira, clear.
Yeah. Yeah. Okay. So, and one more thing, this service block we can add in the same YAML file of deployment by giving these 3 lines. Or you can create separate service also, no problem. I mean, separate service YAML instead of calling the same deployment YAML. I will show you now that once cluster is created. So this is the process of to understand the three kind of services. Okay. Still it is going. Okay. And the next concept is quickly we can do this one also. And after that important concept is horizontal scaling up the pods. So guys, if you can see these worker node components or whatever. So if you can see this worker node components, so I can create a replicas. But these three replicas always maintain three, whether load is there or not. So the concept, what we can understand, this scaling is called static scaling. I mean, the load is there or not, always three should be maintained. For example, if my load is there, my traffic is more on three pods. So fourth pod will not be created automatically. The reason, so the system replica set always maintain these three replicas only whether load is there or not. But how we can apply the dynamic process? So whether load is there, only replicas will be increased. Whether load is not there, replicas will be deleted. Like same auto scaling group. Already we discussed, right? Auto scaling group. So auto scaling group, when the load is there, as per the CPU utilization, increase the servers count. If the load is not there, decrease the servers count. That is taken care by auto scaling group. So in there we have already defined minimum set point, maximum set point, CPU utilization. And here also same process similar to the process like a load balance, like auto scaling here also to enable the dynamic process. Okay, nodes will be created. So, kubectl. Okay, so I'm able to see my two nodes ls. Anyway, this server and we have a deploy these many files here. CD Kubernetes. Okay, cluster IP.ml, load balancer.ml, node port.ml. So let's go to node port.ml here. So as I said, you can create this service separately, or you can add here also, whatever. So if you can see here, this is service.ml, type node port, selector is my app np. So here labels also my app np. That's what it is going to be accessed. This is port, service port. Target port means where your container, application is running on which port. And next is node port. Okay. See, we'll allocate a port from a range default 30,000 to 32,767. So node port, if you define, same port will be allocated in between the range. If you are not defined, also no problem. By default, Kubernetes will be allocated. Whenever you can select the node port option here, by default, Kubernetes will be allocated node port here. Okay. So this is optional field. Okay, let's see now. So by default, this service port also we can give like a target port. The recommendation is here 30,000 means here also 30, sorry, here Node.js application 3,000 means here also 3,000, and means so better to give this port, the service port also same as a target port. That's what by default, and for convenience, the target port is set to the same value as the port field, target port field. That's what it is also here. So containers are creating. It will take some time. After that, pods also will be created. Okay. Now, how to check the service? Same kind of command only we are going to use kubectl get service, or you simply we can give shortcut svc. Yeah, if you can see, I have given my node port is 3007, but system also allocated the same 3007 port. Okay. Okay. And now, how to access node IP? Sorry, this is not node IP. This is your server environment. So node IP means you have to understand the two nodes will be created, right? In which region? Mumbai region. So you can take any one of the node IP, and we have already created node port, and we can access. It is, we'll see here. Okay. So take any one of the IP, and my node port is, what is the value of node port? 007. So give IP 3007. Okay. So we are unable to access this range, right? So I'm saying my node inside my node pod is running. So I'm using node IP, node port. I'm trying to access like this process. This node I'm taking. So my end two nodes are there. I'm taking any one of the node. This node IP, node port. I'm trying to hit. But this node and security groups are there, right? These security groups will check any port enable or not. So this is node. Go to security groups. So here my inbound rule is throughout source is only inside the SG only it will work. So we need to enable this is or you can create a one more rule, but this is action. So we have created through CLI command, right? So that's what default behavior. But whatever restrictions are rules if you want to enable while creating cluster through Terraform, we can define all traffic or whatever traffic this SG groups details. But I haven't specified any SG group details through CLI. That's what default behavior is. It will work through only inside the cluster, not from external traffic. So that's what I'm enabled additionally to access from external. Now you can access, you can refresh. So I'm able to access my Nginx. My Nginx is running in pod. My pod is running in one node. So that's what I'm accessing. Node IP, node port with help of service. I'm able to access my Nginx. Any questions? You can take any node. So my end is two nodes are there. My pods are running both nodes. That's what I can take any node. Any questions?
Clear, Veera.
Yeah. Okay.
It's clear, Veera. No questions.
Okay. Let's go to now. Now ls. So my end is node port already running, right? Let me delete node port process. So you can delete kubectl get pod and delete pod. So take the pod name and kubectl delete pod and pod name you can run, or directly kubectl-f. You can delete like this by using YAML files. Apply in place of delete if you can give whatever pods will be created by using this YAML file, everything will be deleted, including service also. Why? My service also there in the same YAML file. That's what service also deleting. Our next process is cluster IP process. So this cluster IP process, VI, the process is same. There is no any difference. In place of Kubernetes service node port, so here is we are using cluster IP port. That's it. There is no difference. Everything is clear. But we need to understand one thing. So here we are using node port is for external node port, and load balancer is for external communication, and uh, cluster IP is for internal communication. Okay. Let me deploy this. This is a cluster IP node type, and we need to understand here these three lines why we are using. If you're adding one more YAML file, give a 3 lines and start one more YAML. If you want to add one more YAML also same file, give a 3 lines and start one more YAML here. So that's what this service is related to this deployment. That's what I'm using in the same deployment YAML. Or you can separately create. Even if you can create separately also, both can communicate based on these labels. Okay. Okay. So just a minute. Sorry. Okay. Now kubectl get pods. So 3 pods are running. If you want to check along with the node details where exactly pods are running on which node, simply you can give -o wide kubectl get pods -o wide. If you can give, we can see the information in wide angle, so that we can see the pods are running on which node. We can see the node details and etc. So these are pod IPs, internal pod IPs. Okay. And kubectl get svc. See here, I have created a cluster IP. So this is for only internal communication. So it is not possible to access from external communication. So that's what node port is created here. So it is not possible to access from external. So cluster IP is the service to communicate only internal communication purpose, one pod to other pod. For example, front end pod has to communicate to backend pod. Backend pod has to communicate to DB pod. In this kind of communications are required so that we can create cluster IP process. Okay. And finally, load balancer service time. So let me delete this again. Delete hyphen deleted. And the next process is load balancer type. kubectl apply. Excuse me. So kubectl get pods. So second pod is running, container is creating state. Now you can check, maybe now it is created. Still it is creating mode. Okay. So kubectl get SVC. See here, load balancer is created. This is load balance river. If you want to check, my cluster is running in Mumbai region, right? My cluster is running in Mumbai region, right? If I load balancers list here, I'm able to see now created load balancer. So Kubernetes created this load balancer. If I click on this, so we can see the network details, security details, health checks, target instances. Two instances are target for your load balancer, monitoring, and etc. Okay. So you can take this load balancer. See, I'm able to access in Unix. See, this is recommended action, access through load balancer. Clear? Any questions?
No, clear.
Yeah. Okay, these are the services concepts in Kubernetes. And the important thing here, I can see here my pod number of pods are 3 is running, but always these 3 pods maintain the same constant status. If you my traffic is more on these 3 pods, even the fourth pod will not be created until you can increase the pod. Okay, so this is not this is static scaling process, whether load is there or not. See, now at this time no one is accessing my load balancer, even me only accessing, even the 3 pods are running. So whether load is there or not, by default the replica set, whatever the set point you have given, those will be created. Then how to make it the dynamic process? kubectl delete hyphen app. Let me delete this process. Okay, the concept is now horizontal auto scaling. So same thing, deployment YAML is same like your deployment YAML, no difference. Same like your deployment YAML, no difference here. So here, but the thing is here, I'm going to horizontal pod auto scaling concept here. This horizontal pod auto scaling is nothing but, so we have an additional YAML file in between deployment and service. This YAML file will help to give a replica count to deployment YAML as per the traffic. If I open this deployment YAML, see here, my replica is only one. My image is Nginx 1.7.9. So you can give any image. So let me open my Docker Hub now. I can give my image also. You can give ECR image also. So ECR insert repo also. Yeah, so I'm taking here. You can take any image here. These are my images. Okay, these are my images. We push right in the last class. Few images we push into Docker Hub register and ECR, right? So I'm taking one image here. Copy. So here I'm just changing my deploy.ml image. Okay, anyway, my own same image, not updated. Cool. So here we need to understand one thing, the container port. Not here, even you can give here. Okay, so here we can get a better clarity. Yeah, so how, okay, this is my sample deployment YAML, but if I create a deployment YAML, only one replica will be there. If the traffic is increases, so someone has to come and increase the set point replica 1, 2, 3, 4, 5. That is again static scaling. But the traffic will increase automatically. Your YAML file has to increase the replica count, but it is not possible alone. So that we are taking help from horizontal pod auto scaling. So this is horizontal pod auto scaling YAML file. If you can see, API version is auto scaling /v2. Kind is a horizontal pod auto scaler. Metadata. So metadata is name of the horizontal autoscaler. Specification. So here the specification section, we have to define this block. And this block is under specification of horizontal autoscaler, we have to give target reference. Target reference is nothing but API version apps v1 kind deployment name Nginx HPA. These three blocks is nothing but here we can see these three blocks only. I mean, my HPA.yaml is calling the deployment.yaml. When it will call, that is very important. When it will call, go to HPA.yaml. When it will call, the minimum replica is 1, maximum replica is 10. So I'm calling the deployment.yaml. I'm giving the set point, minimum is 1, maximum is 10. And which case, sorry, and which case the value, the replica will be increases. So the depends on this matrix. So my matrix count, CPU matrix count. So when it is reaches to utilization greater than or equal to 1%, so immediately this HPA will trigger the deployment YAML and give the replica count is 2. Increase. Average load should be 1% it has to maintain. And again, still two pods are maintaining 1% average load. So now third pod will come. So three pods average load maintaining 1% means still traffic is more means fourth pod will come. So till 10 pods it will come. If you need 11th pod, again you can come HPA and change the set point only. Okay. So how your HPA is calling to deployment YAML by scale target reference. So scale up, scale down with reference of deployment YAML. So horizontal pod auto scaling call to deployment YAML and increase the scale or decrease the scale based on the CPU utilization. Same like auto scaling concept, what we discuss here. Okay, and let me start the process now. So kubectl apply -f dot. So whenever you can apply -f dot means current directory, all YAML files will be executed here. The YAML file deployment YAML file is to deploy the application. Service.yaml file is to give the access. HPA.yaml file is to increase the replica count or decrease the replica count based on the CPU utilization. So whenever I can execute here. So kubectl get pods now. Okay, still container is creating. Yeah, ready state. So you can access kubectl, get SVC. So that this service type is load balancer service type. That's what it is created. Copy. Yeah. So accessing my application, I am giving the images, my image, Docker Hub image after deploy the Docker file. So now still, if you can check the kubectl get pods. So whether the traffic is more on my load balancer endpoint, this pods count will be increased till 10. So you can, even we can get the HPA details also. HPA means horizontal pod autoscaler. Kubectl get HPA. So minimum pod is 1, max pod is 10, replica is 1. Still only one replica is there. And CPU given set point is 1%, present set point is unknown. So we need to understand very important concept here. kubectl top pod. If I give this command, this top command will work to check the load on pod. Present load on pod, how to check? With help of top command. But top command is not executing. Top command is not executing. The reason metrics API is not available by default. Metrics API is not available by default. So what we need to do here, we need to install metric server inside the cluster so that metric server will calculate the load on every time tops and nodes so that we can find out the load exactly. So how to install the metric server? Come to the running nodes here, Control F. So metric server deployment process, the Kubernetes metric server is aggregator of resources, usage data in your cluster, and it isn't deployed by default in Amazon EKS cluster. So it is not available by default. So we have to install by using this deployment process. So here we need to understand one more important thing here. kubectl apply -f. So even you can apply directly kubectl apply command by using this GitHub URL also without cloning. So it will support kubectl apply -f. This GitHub URL link means this YAML file will be applied. Same process here also we can understand. So components.yaml inside my metric server details are there so that if we can install this process, metric server installation process, kubectl apply -. So any installations required inside the Kubernetes cluster, those installations we have to follow through YAML file only. So you can install by using any command, no problem. But I'm installing by using Google is giving this command to install metric server. So that's what I'm installing this process. So the background to work with metric server, these many configurations are created, pods and something and all. If you want to check your created metric server, you need to go kubectl get deployment metric server -n kube system. I will tell you what is kube system here. So kubectl get deployment metric server means the details metric server is a running state. Okay. Yeah, now running state. So -n kube system is nothing but what? So metric server is nothing but we are installing metric server. That's what kubectl get deployment metric server. But what is -n kube system? So -n is nothing but namespace. So inside cluster, we can deploy multiple pods, multiple services, multiple different configuration and different name system. So kubectl get pods. This is meaning is -n default default namespace. So default namespace, no need to define. That's what kubectl get pods means. We are able to see pods running on default namespace. But my metric server is not running in default namespace. The reason kubectl get ns. If I give my Kubernetes inside namespace, we can see here the list of namespaces. See, default namespace. If you're not specifying any namespace, where exactly pods and services are creating in this default namespace. And this kube, public kube, system kube, node list. These are inside system configurations. If you do any metrics or monitoring, anything, those will be configured as per the name systems. And also we can create your own name system, kubectl, create ns demo. So I have created a name system demo. So you can again give up arrow and get ns namespaces or Kubernetes. So demo also there. Now created just now, 6 seconds age is. And I can run my pods in this particular namespace also, so that if you want to check the pod, kubectl get pod -n namespace. If you can give the running pods on the demo namespace, we can able to see now. If you not specify any -n namespace, those pods will be deployed in default namespace, like a workspace. So that's what. Okay, anyway, now you can check the kubectl top command. We can see now. Okay, see, I'm able to see my load on my my pod, CPUs and load on my pod. The reason top command is working fine. The reason I have installed metric server. So meanwhile, you can check kubectl top node command node also. We can check the node load. Sorry. See, my node present memory is 50%, 41%. CPUs are 2%, 2%. These node are nothing but EC2 instances. Now you can check kubectl get HPA. So my horizontal pod auto scaling. Now you can see your actual percentage set point. You have given 1% for your horizontal pod auto scaling, and the present load is 0%. No load. If the no load is means still one replica is enough. Then how to increase the load? We can increase the load to get the more details. Okay. So what I'm going to do now, excuse me, I'm going to increase the load. So to increase the load, we have a stress command here. So vi test.sh. This is a sample shell script. I mean, for by using for loop, we are hitting this load balancer URL times 1, 2, 3, 4 till 1,000 times by using. Okay, first time call it will hit. Second time call it will hit. Third time call it will hit. 1,000 times this will be hit this URL, so that load will be increases to check your pod status, HPA status. But here we need to change one thing. This is the load balancer URL. And insert. So let's change the URL here. Okay, escape WQ. I'm increasing the load to test this lab actually to check the how HPA will work and increase the pods. For checking purpose, I'm running this command. So test.sh, I want to run shell script. How to run the shell script by using sh test.sh. So that the script will run. Where this script will run, your call command will hit 10,000 times. So that load will be increased. So now you can open duplicate tab to check the status of the pods. sudo su hyphen kubectl see now pods count increase. So now check kubectl, get HPA. See here, given set point is 1%, load is 181%. That's what max pods, it is raised to match max pods, your replicas. After some time again, it is going to be 1 minimum pod if there is no load. Clear?
Yes, Vira, it's clear.
And one more, we need to understand kubectl top node. So my node also increased to 92% one node. So even if you can check the pods kubectl, few pods are unable to run. We can find out the issue. Take one pod here, copy how to check the more details. Kubectl scribe. If you can see insufficient CPUs for this pod, two nodes already unable, so no nodes are available for this process. Fail to scheduling a pod. My pod is unable to schedule due to unavailable nodes. All nodes are busy. Whatever two nodes are busy with existing pods. So insufficient CPU. Since I'm taking just T2 small only, right? My node is T2 small. That's what it is not supporting for more pods. Okay. So what we can do, guys, here, we can remove the pods or increase the node count. Simple. Okay. So we can increase the node count or decrease the pod count. So how to increase the node count? My end only two nodes are running. Let's go to here. So whenever cluster will be created, auto scaling group also created. So we ran a cluster by using CLI command. So as I said, whenever you run a command without specifying any minimum maximum count of the nodes, by default system can take two nodes only. So that's what, if you can see, this is the cluster. See, desired to minimum to maximum to. So auto scaling is going to work the background for node high availability. So what I'm going to do, increase the 2 to 4. Desired capacity, if increase 2 to 4, desired capacity means immediately it can be affect, right? Now you can check the nodes instances. Two more nodes will be created. So pending state. One more also will come. Desired capacity means immediately. So one is already running, one is pending state. Refresh. Now you can check. rest-hyphen kubectl get see now no pending state. All pods are creating state. These three also will be creating now. The reason nodes increase it, right? Whenever nodes increasing, so the resources will be so all pods are creating. Now you can check kubectl get nodes. 4 nodes are ready. That's what multiple pods, multiple 10 pods we are going to deploy on 4 nodes. Okay, this is the concept we need to follow. Is this clear or any questions?
Did I have one doubt?
Yeah.
What is the use of namespace and metric server? If I not install metric server, what will happen?
If you not install metric server, this process will work, but we are unable to find out the load exactly. See, now kubectl top node meaning this command is meaning we can check the node CPU's node RAM load. See, the first node CPUs are 106%, second node 2%, third node 106%. So the recently created pods nodes are these two. That's what load is very less. And previously created nodes already reached 100%. That's what no CPU space. So we have created a few more nodes now. But how to find out these CPUs and memories, this load and all percentage and all? By seeing this metric server only. If there is no metric server is running, not running in background, we're unable to see these loads. We don't know what exactly going on in the background. And namespace is nothing but just we can deploy different deployments and different namespace. For example, okay, for example, if you can see here. So namespace we can create manually. Also, we can go with the YAML file also. So if I run this YAML file, what will happen? API version, namespace, metadata. In here, by using this 4 lines of YAML, I'm able to create a demo namespace. And I'm going to create a pod, but in the metadata section, additional entry is namespace entry. I'm saying that this pod don't deploy in default namespace, deploy in created namespace only. So copy, and if you can create here ns.yml namespace.yml, just paste here. Now what will happen if you run this? kubectl apply -f ns.ml kubectl get pods. And here -n, you have to give demo namespace. So these pods are running in demo namespace. That's what see created pod we can see in the demo namespace. But this pod is not running in default namespace. Inside cluster, we are creating multiple isolation namespaces. So we are separating this YAML file, these pods and all. Clear?
Yeah. Yeah, but I have
If
one more doubt.
If
But
I give
here,
kubectl get pods here, we're unable to see this pod in their list. See, my app is not there here. This is default namespace are running this poem, and my app is running in demo namespace. Yes, what is your question?
yeah. While creating cluster, we are getting default 2 nodes, right?
Yeah, yes,
Yeah, but if we are increasing manually here, our additional 2 more, right?
yes.
But while creating, we can increase like while creating cluster, we can define like extra 2 more ports. Like
That's what I'm saying right here. So while creating a cluster, if you define these 2 blocks also here, if you define here hyphen nodes minimum maximum, if you define minimum 3 maximum 3, so always first 3 nodes will be created, not 2 nodes. If you follow these 2 entries, so that we can define how many nodes required. If you're not define anything, so that cluster will follow the default action, maintain 2 to 2 only. Understand?
Yeah.
Let me add this block also from tomorrow so that we get clarity. Yeah. So I can give here minimum 4, max 5, or minimum 3. So whenever I create a cluster, this will be created. Nodes also. If you're not defined means by default it will create 2. Any questions? Meanwhile, I'm going to I'm deleting a cluster. So any questions, guys? Are you clear? The process and all? So work with day for horizontal scaling and names. Day 3, day 4. These 3 you need to work. Day 3 services, day 4 horizontal scaling, day 4 namespace. You need to work with these 3. Already GitHub link is there, right? Please practice on this. And nodes also, I'm going to share the entire nodes. So here you can find out metrics, like find metrics. You can install a metrics server. Clear? Any questions? Okay, guys. So I can understand silence means no questions. Thank you. Bye bye. Tomorrow we can discuss next topic and Kubernetes. Bye.
Yeah. Thank you, Viren.
Yeah.
Thank you.